So conversely, if you think about how a negative correlation would work, that would be, say it's a negative zero point 0.5 correlation. So variable A goes up 1 unit, variable B, instead of going up zero point 0.5 units, goes down zero point 0.5 units. And it's important to note that you start out at 0 with correlations, and as you approach -1 or 1, they get stronger. A negative zero point 0.9 correlation is just as strong as a zero point 0.9 correlation that's positive. It's just in the opposite direction. So here's where we get, we start to get into the interesting stuff, because there's a lot of problems with correlational studies, or rather there's a lot of weak points of them, because they try to get all of those advantages of case studies and experiments. There's a lot of factors that you can kind of point out and that are weak points, both for when you're researching for your own case and when you are coming up against a rebuttal and trying to refute a key piece of evidence in another case. So talking about problems with correlational studies, firstly, a weakness is that conclusions about a population must be drawn from a sample. So when I say that, think back to the kindergarten classroom, right? We've got, 5 kids that we've asked now about their favorite ice cream flavors. And again, maybe the whole class likes strawberry, and except for that one kid who likes chocolate. I've asked the one kid who likes chocolate and 4 other people who like strawberries. What I infer is that 80% of the classroom likes strawberry. But that's not really true, is it? Based on my sample, I've got 4/5 of the classroom sort of sampled, and I'm assuming that there are 4 more people in that classroom that like chocolate ice cream, when in reality, that's not true. Not only that, but if you think about the kind of variables of interest we're interested in the world, maybe I'm interested in friendliness. Maybe I'm interested in how often people give birth. And so what's really important is, if I'm going to try to generalize to a whole population, I really need to get a representative sample. That means demographically representative, so age, physical characteristics maybe, if that's relevant, race, gender, disability, LGBT, any kind of individual difference variable that's really going to matter. I need to make sure that my sample matches the population as closely as possible, and that's never possible. So don't think you're going to ever get, perfect random sampling. It's really a pipe dream, but you can get ones that are pretty close. And if maybe you're talking about a study about views on race and racism that's endemic within our culture, and the sample only includes white people, well, there's a problem, right? The next thing is the correlation coefficient. You'll also hear I'll toss out a few other terms here. You don't necessarily need to know how to calculate or, work with all of them. But if, you go up in a cross-X and you ask your opponent for the correlation coefficient, they don't have it. They might give you instead, you can have an effect size, a Cohen's D. What else am I'm thinking of? They might give you an alpha. That's a measure of significance. Sometimes it's a measure of internal consistency. Basically, what you really want to do here is just get some kind of value that measures the effect. They really should have, in just about any study. I really raise an eyebrow when I hear somebody in a round say, oh, I don't have a correlation coefficient, because that says to me that they're not reading their research right, or they're drawing on some weird research, in which case there's probably something else you can poke there. The last problem is that you can't determine causality, right? And this is, a very classic example, but bear with me. If I find that there's a correlation between ice cream sales and shark attacks, right, there's 3 possibilities of causation within a correlation. There's A, that A causes B. So in this case, shark attacks cause ice cream. Well, probably not, right? That's kind of strange. There's the second option is B causes A. Okay, ice cream sales cause shark attacks. Still kind of weird. And then the last one is that it might be a spurious correlation, which means that it's the third option. C, an unrelated variable, causes both B and A. In this case, both shark attacks and ice cream sales are correlated with hot weather, right? And in retrospect, a lot of times things like that make a lot of sense, because hindsight's 2020. But it's really important to be thinking about how that might be happening within the research that you're presenting. So, last kind of slide here, as a takeaway. Here are really, kind of a little laundry list for you to be pointing out in some research. So good research has a high N. N is number. That's the number of participants. And again, think back to that children in the classroom example. The more people you have in your sample, the better chance you have that it's representative of the population. So if you're trying to generalize to the United States of America and your research has an N of, 100, chances are you're probably going to have some sample bias somewhere in there. You're probably not going to capture the whole population. So that's a great argument to be making within round. Again, that's that sample that reflects the population, high N. Good research is also a lot of times longitudinal. And what I mean by that is that it happens over the course of time. So maybe you track these kids. Maybe you really want to find out, your variable of interest is what do children K through 12 like for their favorite ice cream flavor. And if I sample only a classroom of first graders, well, that's not going to give me that much. But it's also not going to say there's, a really big new promotion. There's, a huge, huge ice cream festival, and one ice cream truck comes to town, and it's like, yeah, we've got Neapolitan ice cream in this town. It's so excited. This town has never had Neapolitan ice cream before. And everyone goes nuts. Well, then your sample data is going to be affected because you're trying to figure out, what do kids K through 12 really like for their favorite ice cream. So not only do you need to be taking into account the population, where you need to sample first graders, second graders, third graders, fourth graders, fifth grade, or at least like every third grade or something like that. But you also need to take into account any kind of temporal effects. And in this case, that's that ice cream truck coming to town and everyone getting really, really hype on the Neapolitan train, right? And one way that you can combat that is by doing your research over time. So every 3 years, maybe, these surveys go out to Polk County Elementary School in the middle of nowhere, North Dakota, and everyone fills out their favorite ice cream flavor. So then Neapolitan appears as one data blip, but you can really confidently rule out that it wasn't just a longitudinal effect. The opposite of that is cross-sectional, which is when you just get one point in time. And again, this is one of those things that, most research is going to be cross-sectional because it's really hard and really difficult to set up longitudinal studies like that. But it's definitely something that, if you can make a good case, like I just did for the ice cream, could really affect the debate. Obviously, you want a high correlation coefficient or effect size. Some other things are that you really want to look at, unbiased funding, right? You don't want a pharma company funding a drug trial research study because they've got a vested interest in making sure the product looks good. You also want an author with good credentials. You don't want John P. Goodman saying, oh, well, drug X definitely cures depression. Look at me, I'm a celebrity. You gotta believe me because look at all the sitcoms I did, right? It's not relevant. You want somebody who's been doing research for a while, somebody who, works somewhere where they would have gotten the experience, whether that be in a, think tank. Most of the time it's going to come out of academia. That's where a lot of peer-reviewed research happens. Yeah. That's about all I can think of right now. So, last slide here. Questions and more. Let us know if you've got any questions, if you've got any feedback. We love to hear from you. We've got a good amount of people signed up. We're really excited to pilot this camp this year for a number of reasons. We really want to be promoting access, and we really want to make sure that we can keep communication up to you guys as good as possible, be providing feedback, and just an all-around good educational experience. So please let us know if there's anything we can be doing better at debatecamp.tumblr.com, boxerinstitute@gmail.com. The Boxer Institute for Debate and Speech Facebook page would be great if you could like that. We'd really appreciate it. And then it's just a couple of reminders. Assignment 2 for this research dooleyhood will be sent out on Wednesday night. Remember to complete assignment 1, so Nick's assignment that from his previous week, by Wednesday as well, so you can get to work on this one. Thanks, everyone. See you later.